Good morning, pre-calc. Coach Jackson here. Hope you had a good day. We're going to look at finding imaginary zeros now that we've talked about what an imaginary number is. We should be in section, I think this is the fifth section of Unit 2. So we're almost to the end. And if you take what we learned in the third section and the fourth section where we did the synthetic division and talked about complex and imaginary numbers, you should have no problem with this section. So in this first example, we want to find all the possible zeros and all of the actual zeros for x cubed plus 6x minus 7. Of course, going through the rational zero test, we find the factors of -7 and the factors of 1. So all of my possible zeros are right here. Okay, so we're going to try 1. Notice that I have no x squareds up here. So I'm going to put a 0 as a placeholder. Okay, so we're going to try 1. I've got 1, 0, 6, -7. I tried 1. It worked because I have a 0 as a remainder. I've got it down to a quadratic, so I should either be able to factor it or use the quadratic formula to help me factor it the rest of the way. Okay? So I know that x minus 1 is a factor, and now I need to factor the rest of it. Well, it won't factor because there's no factors of 7 that add up to give me 1. So I must use the quadratic formula. Okay. So in this one, my A is 1, my B is 1, my C is 7. Put those into the quadratic formula. And lo and behold, I end up with a negative under the radical. That makes it imaginary. So I've got to put an I out front. And I need to simplify the radical. So let me run through you with you here. Put an I out front. Okay. Now the question is, can I simplify the square root of 27? Well, I can if there's a perfect square that's a factor of 27. Square root of 27 is the same as square root of 9 times square root of 3. That's 3 root 3. That's how I get this answer. Okay. So this cubic function has one real root and 2 imaginary roots. So when you graph it, you're only going to see it cross the x-axis one time, even though it has 2 more roots. They're imaginary, you can't see where they cross. Okay. Next one. We've got a polynomial function with a last term of 3, first coefficients of 1. So we've got 4 possible roots, rational roots. So we want to try -1 first. Okay. So if I try -1 first, I've got coefficients of 1, -3, 1, -3. So break down with 1. 1 times -1 is -1. I add, I get -4. -1 times -4 is 4. I add, I get 5. 1 times negative 5, or excuse me, negative 1 times 5 is negative 5. I get negative 8. Let's make sure I wrote it down right. What did I miss? I missed my squared terms. There should be a 0 in the middle. Okay, there should be a 0 in the middle term. Again, biggest mistake that students and sometimes teachers make. So let's try this again. See if it works out better. 1 times negative 1 is negative 1. That's a negative 4. We get a positive 4. We add. We get a negative 4. We get add. And we get a positive 3. And we add. We get 0. Okay, much better. So negative 1 is a root. X plus 1 would be a factor. So what I have right here, I started with an x to the 4th. So this is going to be 1x cubed minus 4x squared plus 4x minus 3. Okay. Where do I go from here? Well, I need to pick another one of these possible rational roots and try and factor. Okay. Let's pick, I don't know. So what do? To take the guesswork out of it, why don't we graph it and get a look at it? So if I graph this on my calculator, let's bring that up here. All right, so we can graph it now. I have an x cubed left minus 4x squared. Or do I want to graph the original? I need to graph the original. Let me graph the original here. That was, graph the original. That's x to the 4th minus 3x cubed plus x minus 2. Minus 3 there. So let's graph that in the calculator. So x exponent 4 minus 3x cubed plus x minus 3. Graph it. So it looks to me like it crosses at negative 1, which it should. We figured that one out. But then the other one looks like it crosses at positive 3. So let's go ahead and do the math, the synthetic division with a positive 3. Okay. So 3. And I'm going to use these numbers, 1, negative 4, 4, negative 3. Bring down my 1. I'm going to multiply and add. And 3 works, which it should. We saw that on the graph. Okay. So I now have x squared minus x plus 1. Now the question is, can I factor x squared minus x plus 1? Are there factors of positive 1 that add up to give me a negative 1? No, there's not. So I'm going to use a equals 1, b equals negative 1, c equals positive 1, and I'm going to use the quadratic formula. So I'm going to fill in the quadratic formula. So I have 1 plus or minus the square root. It's going to be 1 minus 4, which is a negative 3, all over 2. That's 1 plus or minus I root 3 over 2. So there's my other two imaginary roots. So negative 1 works, 3 works, and then here are my other two. They're imaginary roots. Okay, there's 2 of them. So you guys try this one. Pause the video and factor x to the 4th minus 12x squared minus 13, just as a little side practice, and come back and we'll go over it. Okay, so if we want to factor x to the 4th minus 12x squared minus 13, we may be able to factor this without doing anything rash here. So let's see if we can factor it into 2 binomials. What are my factors of negative 13 that add up to give me negative 12? Well, there's only 2 factors of 13, 1 and 13, and the middle term is negative. So negative 13 plus 1 is negative 12, and the square root of x to the 4th is x squared. So this should factor into x squared plus 1 and x squared minus 13. Okay. X squared plus 1 does not factor. X squared minus 13 does not factor. But here's what happens. If I take x squared plus 1, set it equal to 0, I get x squared equals negative 1. If I take the square root, I know that that equals I. And i's have to come in conjugate pairs, 1 plus and 1 minus. If I do the same thing to this one, I get x equals plus and minus 13. So plus root 13 minus root 13. Okay. So if an imaginary number is ever a 0, then its conjugate is also a 0 for that polynomial. So if positive I is a 0, then negative I has to be a 0 also. And that's because the quadratic formula always gives us a plus or minus I. So next one, we want to find the polynomial with zeros of 0, 1, and I. Well, we got to know if it's a positive I, we're going to have a negative I as a 0 also. So if I have a 0 of 0, I know I'm going to have an x. If I have a 0 of 1, I know I'm going to have x minus 1. And if I have a plus I and a minus I, I'm going to have an x minus I and an x plus I. So here they all are. That gives me a 0 of 0. That gives me a 0 of 1. That gives me 0 of positive I, and this one gives me a 0 of negative I. So I need to multiply those together. I'm going to multiply together x times x minus 1, and I'm going to multiply together x minus I times x plus I. Because I know if I do that, I'm going to get an I squared. Okay? And I squared equals negative 1. So if I multiply these together, I get that. And if I make that a negative 1, I get a positive 1. Now I can continue to multiply these two together and get a final polynomial of x to the fourth minus x cubed plus x squared minus x. Next, we want to find the polynomial with zeros of 3 and 3 plus 4i. Well, if I have a 3 plus 4i, I'm going to have a 3 minus 4i also. Does this look familiar? Where we had all the parentheses and I showed you the shortcut on how to do these. So we only want one set of parentheses. How many x minus 3's do we have? We have 2. If I multiply negative 4i and positive 4i, I get a negative 16i squared. I can replace that I squared with negative 1, and I end up with a positive 16. So here's the factor for the 0 of 3. Here are the two factors for 3 plus 4i and 3 minus 4i. I just did a little shortcut to multiply. So if I multiply x minus 3 all squared and add 16 to it, I get x squared minus 6x plus 25. And if I multiply that by x minus 3, I get that final answer of x cubed minus 9x squared plus 43x minus 75. Again, please pause the video if you need to catch up with any notes. All right, next one. Find the zeros of x to the fourth minus 4x cubed plus 12x squared plus 4x minus 13, given that 2 plus 3i is a 0. Well, if 2 plus 3i is a 0, 2 minus 3i is also a 0. So there's our two zeros. We multiply them together because I have 2x minus 2's, and 3i times negative 3i is negative 9i squared. And I'm going to replace that I squared with a negative 1. So I end up with x squared minus 4x plus 13. Well, that takes care of two of my factors. I've got to figure out what the other two are, because I should have 4 roots. Right now, I've only got 2. So I need to take this one right here and divide it into this one up here. So we're going to do some long division. Okay. So I've got my x to the fourth minus 4x cubed plus 12x squared plus 4x minus 13. And I'm going to divide it by x squared minus 4x plus 13. What do I multiply x squared by to get x to the fourth? Well, I can multiply by x squared. X squared times x squared is x to the fourth. X squared times minus 4x is negative 4x cubed. X squared times 13 is 13x squared. And I'm going to subtract. That cancels, and 12 minus 13 is a negative 1x squared. And I bring down my 4x. What do I multiply x squared by to get negative x squared? Negative 1. So negative 1 times x squared is negative x squared. Negative 1 times 4x is positive 4x. And I'm going to go ahead and bring down my negative 13. Excuse me, that goes right here. And negative 1 times positive 13 is a negative 13. Put that in parentheses and subtract. Get a remainder of 0. X squared minus 1 is the rest of my answer. X squared minus 1 is x plus 1 times x minus 1. So that gives me the 1 and the negative 1. So those are my zeros. All right. Please join the Zoom if you have any questions, or email me and I'll get back with you. Have a good day.